Okay, our topic is indices, and we have already discussed about the laws of indices. Laws of indices we have discussed already is laws of indices. Now today we have to discuss few questions. Few questions I have modified myself, and very interestingly, we can simplify a problem. We can simplify this question. The question is given like this way, that x square minus y is to the power minus 2 divided by x to the power minus 1 minus y to the power minus 1. This question is given, but I change this in this pattern. I make it minus x to the power minus 2. I had changed this pattern because uh, the pattern is just x is given, we will get the answer, but that is not so good question. That's why I have little modify this question. Anyway, now we have to solve these questions. Don't worry about the answer, but the process is important. Yes, x to the power minus 2 minus y to the power minus 2 divide by x to the power minus 1 minus y to the power minus 1. This is a question. Then dear students, it can be written as x 1 over x square plus 1 over y square. This is the numerator, and this is the denominator, 1 by x minus 1 by y. As the power is x to the power minus 1, x to the power minus 1 is 1 by x, according to the laws of indices. Yeah. Then the next step is sorry, here minus signs. This is minus sign. Yes, 1 over x square minus 1 over y square. Then taking LCM in numerator, x square and y square is LCM. Then it goes to multiply y square, it goes to multiply x square, and whole over this is y minus x over xy. Y times 1, y times 1 times x. Then if you have given a by b divided by c by d, then you can write a by b times d by c. That's why y square minus x square over x square y square times, it goes up, xy over y minus x. Then y square minus x square is y plus x times y minus x over x square y square times xy over y minus x. Then this can be cancelled, and using laws of indices, y plus x over x is x2 minus 1 y2 minus 1. It means it has 1 power. Here also we can make 0 power and we can make 1, but that is considerable. Then here yeah, y plus x over x square is x, 2 minus 1 is 1, and y square minus 1 is y. This is the answer for this question. Here I have just applied the power rule or indices rule, that 1 power subtracted here, y to the power 1 is also subtracted here. So we can solve this question in this format. For this question is the solution. And the second question is 7 to the power x plus 1 plus 3 times 7 to the power x over 7 to the power x times 3 minus 7 to the power x minus 1. And solution is, if we have given a to the power x plus y, then we can write a to the power x times a to the power y. This is a law of indices. That's how we can separate this. The solution, once I have to repeat, 7 to the power x plus y plus 3 times 7 to the power x over 7 to the power x times 3 minus 7 to the power x minus 1. Then next step is you can break this, or you can change in this form, product form. So it is 7 to the power x times 7 to the power 1 plus 3 times 7 to the power x all over 7 to the power x times 3 minus 7 to the power x times 7 to the power minus 1. And taking common in numerator, 7 to the power x is common, here remaining 7 plus there remaining 3 over here 7 to the power x common, here remaining 3 minus 7 to the power minus 1, and it makes power 0 and it will be 1. Then yes, so 7 plus 10 7 plus 3 is 10 and 3 minus 1 by 7, as 7 to the power minus 1 is 1 by 7. So 10 divided by 7 3s at 21 minus 1 by 7 equal 10 divided by 20 by 7 equal 10 times 7 goes up 7 by 20. So this can be cancelled, then 7 by 2 is the answer. This is the next question. Now we have to simplify other long question. Now simplify other long question, that is x to the power a plus b by x to the power c to the power a minus b times x to the power b plus c by x to the power a to the power b minus c times x to the power c plus a over x to the power b to the power c minus a. The solution is this is it occupied more space that I will not copy again, that directly I will go to the solution, dear students. In this case we have to simplify this numerator and denominator at first. That will be easier, instead that subtracting c in the numerator. So upper one is x to the power a plus b times a minus b over x to the power c to the power a minus b times, this is x to the power b plus c times b minus c over x to the power a to the power b minus c times x to the power c plus a to the power c minus a over x to the power b to the power c minus a, because it can be converted, it can convert into b square minus c square or a square minus b square form. Here simply we can find the product. So this technique will be easier to simplify this question. So upper one is x to the power a plus b times a minus b, that is a square minus b square, over x to the power c times a minus b is x to the sum ac minus bc in order I have written. Similarly here x to the power b square minus c square over x to the power ab minus ac I have written here. Then x to the power c square minus a square over x to the power bc minus ab, the product of power to the power. Here two rules we have applied. Let me remind you. A by b to the power m equal a to the power m by b to the power m in this step, and here we have applied a to the power m to the power m equal to a to the power mn. So we did this. So in the product from numerator you can simply take x and add the power plus b square minus c square plus c square minus a square whole over x to the power ac minus bc plus ab minus ac plus bc minus ab. I believe a square cot b square x to the power not over here also ac and ac cot bc, and you can cot all cancel and all cancel. So here also x to the power naught, that is 1 over 1 equal to 1 answer. So here we have used another law, that is x to the power a times x to the power b times x to the power c is simply written as x to the power a plus b plus c. So these are the question. Next question. X to the power m over x to the power n to the power m square plus mn plus n square times x to the power n by x to the power p over n square plus np plus p square times x to the power p by x to the power m over p square plus pm plus em square. Now the solution is, I will not copy these questions again, directly I will go to the solution, dear students. That's fine. So in this case I think you find the technique that m minus n times m square plus mn plus n square, that a cube minus b cube form of a minus b times a square plus ab plus b square. So while subtracting this, x to the power m minus n to the power m square plus mn plus n square times, here why I have subtract, in previous question just I have multiplied denominator upper part and lower part separately, but here why I have send that is the technique that we can convert this in a cube minus b cube form. That's why I have shifted this means power of this x in numerator, that goes to up, it becomes x to the power m minus n, and their product gives some formula and we can easily solve. That's why I have subtracted n minus p times n square plus np plus p square times x to the power p minus m times p square plus pm plus m square. Then a minus b, a square plus ab plus b square, power to the power will be multiplied, can be multiplied. Then a minus b times a square plus ab plus b square is simply x is m cube minus n cube. Then here x to the power n cube minus p cube, similarly in this step, and all are in similar pattern, that's why you can write p cube minus m cube, and simply add all the power to x to the power m cube minus n cube plus n cube minus p cube plus p cube minus m cube. So m cube n cube p cube chord. That's why you can write this is x to the power not equal to 1. In this way we find the solution, dear students. But it is, the solution is completed, but sometimes you may have given just alternative question. I mean, instead of that, suppose you have given x to the power m over x to the power minus n to the power m square minus mn plus n square, and in this pattern it is given. So in this case what can we do? Then simply you can change this into x to the power m plus n times m square minus mn plus n square. It gives a plus b times a square minus ab plus b square, x to the power m cube plus n cube, and in the same way the answer will be x to the power 2 times m cube plus n cube plus p cube. So this is the reminder, dear students. Don't think always you will get the answer as 1. If you make your mind, your concentration in that way, and you will have some contradiction here, and oh, I didn't get 1, or you may cancel directly, or here you may write the formula m cube minus n cube instead that m cube plus n cube. So according to the question and the instruction, you have to solve the question rather than what you kept in your mind. Okay, so it can be changed, in this pattern, and the answer will not be 1. So this is my request. I reminded you that. So according to the given condition, find the answer and solve the question rather than what is your thought. The question is mn root x to the power m x to the power n times n pth root over x to the power n over x to the power p times pm over x to the power p by x to the power m. And now the solution is, I haven't copied the question again because the space may not be enough. Okay, then let's think how can we solve this. M x to the power m minus x to the power n, that is x to the power m minus n by mn, and n minus p by np, and we can simplify. Let's think in that way. Okay, so x to the power m minus n, first step mn, x to the power n minus p np times pm root of x to the power p minus m. First step is this. Then the second step is x to the power m minus n divided by mn, x to the power m minus n divided by mn times x to the power n minus p divided by np times x to the power p minus m divided by pm. Then all are the power of x, that's why we can add x to the power m minus m by mn plus n minus p by np plus p minus m by pm. Then we can simplify the power index exponent of x. So x to the power mn np pm, can we take the LCM, that is mn m np will be the LCM. Here mn is here, that's why it is p times m minus n, plus here np is here, that's why m times n minus p, plus that pm is here, that n times p minus m. Then x to the power, you can multiply pm minus np plus mn minus mp plus np minus nm whole over mnp. Dear students, just we have multiplied this. Okay, so let me check. pm cot, np cot, mn cot. What we obtained now is x to the power 0 over mnp, that is 0 by something is 0, and x to the power 0 is 1. In this way we can simplify this question. Now next question is a minus c under root 1 over x to the power a minus b times b minus a under root 1 over x to the power b minus c times c minus b x to the power 1 over c minus a. Now the solution is okay. Now this is the order we can divide here, yeah. So simply you can write x to the power 1 by a minus b times a minus c. It goes to divide, that we discussed already. 1 over x to the power b minus c times b minus a, x to the power 1 over c minus a times c minus b. Then all are the power of x in product form, that's why we can add them. 1 over 1 a minus b a minus c plus 1 over b minus c b minus a b minus c b minus a plus 1 over c minus a and c minus b. After that, dear students, we have to think upper part only, we have to simplify. This part only we have to simplify. Let me check what will be the common. A minus b, here b minus a. That's why we need to change the sign. And here a minus c, c minus a. Here we need to change the sign. Here I have t create a minus b, a minus c. Here c minus a, that's why. C minus b, b minus c. That's why again here we need to change the sign. So here once, here two times, it remains the same. So that you know order a b c triangular relation a minus b, b minus c and c minus a. But if you want to do that a minus c, a minus c, if you want to keep, then it will change. So in our comfortable position we can solve this. Otherwise, if you want to make this is c minus a, here will be also minus, here only one sign will change. So in any way we can solve this. Let me check the first what I did. Firstly, that one more step I want to write here. It will be clear for you all. X to the power 1 over a minus b, here a minus c, I keep a minus c, minus here I just change b minus c and here minus making and here order changing, that is a minus b to make this common, and the minus c minus a into a minus c 1, c minus b into b minus c 1, both sign change, that's why it remains the same, a minus c and this is b minus c. And then we can take the common, or the LCM is a minus b, a minus b, a minus b, a minus c, a minus c, a minus c and b minus c and b minus c, b minus c. Now a minus b and a minus c is gone, cancel, b minus c, one time b minus c minus, if here is minus, insert the bracket, b minus c and a minus b gone, a minus c plus, in case of plus directly we can do that, and a minus c and b minus c gone, a minus b. Then next step is, dear students, next step is, after this, x to the power b minus c minus a plus c plus a minus b whole over a minus b, a minus c, b minus c. Then next step is, let me check, minus a plus c minus c, b and b. That's x to the power 0 over a minus b, a minus c and b minus c. That is x to the power not 0 by something 0, that is 1 answer. So I always remind you that if you want to interchange this position, here will be minus sign, minus 1 times something, minus 1 times something and minus 1 times something, you will multiply and you will get the similar result. That order in your one choice you can manage, but while alternating only one term the sign will change. If you want to alternate both the expression, then it remains the same, is plus is plus and minus is minus. Only the important part of this question is that. Now the next question, dear students, that is x plus 1 over y to the power a, x minus 1 over y to the power a whole over y plus 1 over x to the power a, y minus 1 by x to the power a. This is a question. Now the solution for this question, I have not repeated the question, directly I will stick to the solution. X plus 1 by a to the 1 by y to the power a, x minus 1 by y to the power a, all power a. Yes, all power a. So first we can simply we can solve here. All power a we can give you a single power, then xy plus 1 by y, or in product form you can cancel. One part is that. Another part is separately doing. Sometimes we may have given the different power. So in that case we have to apply this rule. So simply I will do this. Here x and y is xy plus 1 over y to the power a. This part is this, xy plus 1 by y to the power a times here xy minus 1 over y to the power a. Here xy plus 1 over x to the power a times here xy minus 1 over x to the power a. First step is this, and the second step is, let's separate them. Xy plus 1 to the power a over y to the power a times xy minus 1 to the power a over y to the power a whole over xy plus a 1 to the power a over x to the power a times xy minus 1 to the power a over x to the power a, just separating in this way. And the next step is then in change in the product form, I know, xy plus 1 to the power a over y to the power a, this is then times here xy minus 1 to the power a over y to the power a, this one and this, and times x to the power a goes off, x to the power a over xy plus 1 to the power a, xy plus 1 to the power a times, again it goes off, x to the power a goes off, xy minus 1 to the power a. Then it's a power, this one, it has same power, then what is remaining, x to the power a, x to the power a, x to the power a plus a, and y to the power also a plus a, simply means x to the power 2a over y to the power 2a, that is x over y to the power 2a is the answer of this question. The question is square equal p minus y to the power y minus 2p over p minus y to the power y minus 1 plus 1 over p minus y to the power y minus 2. So this is very interesting question, dear students. Okay, it's very interesting. Let me solve this, starting this p minus y to the power y minus 2p over p minus y to the power y over minus 1 means p minus y. The power 1 is shifting to the down at the denominator. Here also 1 over p minus y to the power y over p minus y to the power 2. What I have done, this is same. Here minus 1 power is shifted to denominator. Here minus 2 power is shifted to denominator. First step is that. And again in second step, p square over p minus y to the power y minus 2p times it goes off p minus y over p minus y to the power y minus or plus, this is plus, this is plus, it goes up p minus y is whole square over p minus y to the power y, just shifting off. And the next step is p minus y to the power y, p minus y to the power y, p minus y to the power y, that is the common p minus y to the power y, and numerator remains same, 2p p minus y plus p minus y whole square. Then while checking this, p square minus 2p p minus y plus p minus y square, a square minus 2ab plus b square, so it is p minus y whole square is a square 2ab plus b square, that is a minus b whole square whole over p minus y to the power y equal p minus p plus y over p minus y to the power y equal, this can be cancelled, y square equal p minus y to the power y is the answer for this, y square by p minus y to the power p minus y to the power y. Yes, p minus y to the power y is the answer for this question.